Hello all you Algebra 2 students, and welcome back. In Chapter 7 we begin looking at rational expressions. And the word rational is a big one, and to begin with, let's remember what a rational number is. Whoop, a little too big. Let's hold on. So, a rational number is of the form p over q, where p and q are integers, and q is not equal to 0. So, for example, things like 2/3 and 5 over 7, and how about minus 3 over 2, and even 12 is a rational number because 12 can be written as 12 over 1. Okay, so those are rational numbers, should be familiar to you. And what we want to do is talk about what a rational expression is. So a rational expression is of the form p of x over q of x, where p and q are polynomials, and just as with rational numbers, q of x does not equal 0. So here's an example of a rational expression. Something like x squared minus x minus 5 over x squared plus 3x minus 12, or 2x minus 5 over x squared plus 3, or 5 over 3, because both 5 and 3 are polynomials, constant polynomials, and even 15. That's a rational expression. Not one that we'll be very interested in, but that is a rational expression. So remember, we said that in a rational expression, we can't have the bottom equal 0. So think about this very nice rational expression. What are the excluded values? In other words, what can't x equal? And the way we look at that is, and again, here's another application of factoring, is we factor this bottom, and we get this, all right? So the excluded values for this particular polynomial are any values that make the bottom equal to 0, and they're going to equal 4 and minus 3. Those are the excluded values. All right, so a pretty simple idea, but we do have to keep that in mind. So just as with rational numbers, we try to reduce or write in the lowest form, we do the same thing with rational expressions. And we actually do it the same way by factoring. So if you look at this first example, what I can do is take a 3 out of the top, and I get x squared minus 5. Down here, I can take a 3 out, and I get x plus 3. So I can divide out by 3. Really what I'm doing there is multiplying top and bottom by a third. And so this simplifies to x squared minus 5 over x plus 3. And that's in what we call the lowest form, or reduced form. This one's a little bit more interesting. If you remember, we have two terms, difference of two squares, x plus 4, x minus 4. And on the bottom, 3 terms, it's going to factor like this. X minus 4, x minus 2, cancel here and here, and in lowest form, it's x plus 4 over x minus 2. Okay, now, just a point of information. There are students that would think that they could cross these x's out, and they could divide 2 into 4, and hopefully you learned in Algebra 1, and will relearn now, that you can only cross out chunks. So this right here is one chunk, and it's a chunk because it's enclosed within parentheses. Same thing here. This is a chunk. Now, I was able to cross these out because those two chunks expressions were exactly the same. But here, this expression and this expression are not the same, and so I can't reduce this at all. That's the lowest form. Okay, so let's finish with this problem. We want to simplify this. And remember, we're going to try to factor and eliminate common terms. And so on the top, the big first step is to take out a common factor. And if I take a 2k out, I'm left with 2k squared minus k minus 1. On the bottom, I can take a 9k out, and that leaves me with k squared minus 2k plus 1. Okay, that's my first step in factoring. Now I can factor a little bit more. So I get 2k. Okay, I'm going to factor this. And on the bottom I have a 9k, and I'm going to try to factor that. So the top is going to factor with a 2k and a k, a 1 and a 1, and let's see, this has got to be minus, and this has got to be plus. The bottom, you're going to have a k and a k, a 1 and a 1, and a minus and a minus. And so what we notice is we can cancel these terms out, and we can also cancel the k's. And so I finally get 2 times 2k plus 1 over 9 times k minus 1. And there you go. That's in lowest form. All right, so that's our introduction to working with rational expressions. See you next time.